Welcome to Chapter 2. In Chapter 2, we're going to start discussing all about different features of functions, okay? But before we talk about functions, we're going to start to talk about a similar concept, relations. All a relation is a collection of x and y points, okay? A collection of inputs and outputs that are related by some equation, okay? So, the first idea to understand is that there's going to be four ways we can represent these relations, these collections of paired x and y values. The first way is we can list them as ordered pairs. Okay, and this is one that you're very familiar with by now. So the point -3, 4 represents an x value of -3 being connected to a y value of -4. This could also be done with what's called a mapping. So in a mapping, all the inputs are listed, all of the outputs are listed, and then arrows are used to show the relationship. So for example, that point I just talked about, -3, 4, so that is why there's a line from the -3 going to the 4. It shows that those two have a connection. Those are a pair. You could do it as a table of values, which is very similar to how the ordered pairs look, right? It's just in a table instead of written separately. And then, of course, you can also graph them. And in this instance, if all I have are a list of points, that's why all you're seeing are little dots on that graph, okay? All I have are distinct points. So those are the four ways we can represent these relations and functions that we're going to be talking about. Now, with relations, there is another vocab, or two more vocab terms that I'm going to expect you to be able to use, domain and range. So domain is going to be all of the x values in that relation. And then the range is going to be the set of y values. Okay, and so with every different form that we're looking at, of these relations, all the four ways, you can always see what are the x values, what are the y values. So my domain for that relation above, okay, my domain is a list of x values, okay? And again, you can go to any one of them to look for that. I'm going to go in these ordered pairs, okay? Because I can see that -3 is an x value here, 3 is an x value here, 4 is an x value here. And then I'm not going to repeat the 4 because notice I have 4 twice. I'm not going to repeat it. Once I have it in that domain, I'm going to just say it's there. I don't need to write it twice. And for my range is going to be my list of y values. So here I have a y value of 4, have a y value of -1, have a y value of -1 again. So I'm going to choose not to write it a second time because it's already in that list of numbers. And then a y value of 3. Okay, so when you have distinct points like that, that's really all you have to do, okay? Domain, list the specific x values. Range, list the specific y values. So we're just going to make sure we have a little bit more practice doing that. So here, my domain, again, if I'm looking at a list of ordered pairs, my domain is all of the x values. So here I have a 1, I have a 2, I have a 3, and I have a -7. For my range is going to be the list of y values that I have. So that's going to be a 3, a -5, 4, and 2. Over on my next one, again, same thing. If they want domain and range, well, domain is going to be my list of x values. So I have a 5, I have an 8, I have a 1, I have 5 again, so I'm not going to write it a second time in the same list. and a 3. Range is going to be y values. So the range of this thing is going to be 0, 1, 3, 2, and 8. So again, really not too difficult when you're dealing with ordered pairs to see where those numbers are coming from. All right, now let's look at a graph, okay? So when I'm looking at a graph, again, my goal is to list the domain and the range. So my domain, again, when I'm dealing with distinct points like this, when I have distinct points, I'm just going to list what the values are. So I go to this point, and I see that it has an x value of -2. Both of these points right here, notice both of those points go to the same x value, okay? We're going to call that -1.5, okay? Because it's halfway in between there. This point right here has an x value of -1. Here, if I look at the x value, again, it's about halfway, so I'm just going to call that 0.5. That one is sitting with an x value of 1. That point is sitting on the axis, so really easy to see, has an x value of 2. And that one has an x value of 3. So you're just going point by point and seeing what is the x value that we're looking at. And again, I do those lines just to help you see what I was looking for. I was just showing where on the x-axis is that appearing, okay? And you can do the same thing for y. So the range is going to be the list of the y values of each of those points. So here, these 2 points down here, those share a common y value, don't they? So I'm going to look to see where on the y-axis are those appearing. And that looks like -3.5 to me. This one has a y of -0.5. This one is sitting on the y-axis, or is sitting on the x-axis. When I pull it over, it's going to have a y of 0. This one is going to have a y up at 0.5. This one is going to have a y up at 1.5. This one's going to have a y of 2. And this one's going to have a y of 2.5. So again, same idea as with the ordered pairs. All you're doing is looking to see what are the x values, those become my domain. What are the y values, those become my range. All right, and looking at these are even easier to list the domain and range, a mapping and a table. Okay, so here my domain, if my domain is every possible x value, well, that's all the numbers you see represented right there. So my domain, again, is all of my x's that I'm seeing, my range, all of the y values that I'm seeing. And same thing over here. Domain, even when I'm looking at a table, the x's make up my domain. And the range makes up my y values. So now all of those have been for distinct points, right? All of those have been when I just have very specific ordered pairs that are linked. Now, if you remember though, A big piece of algebra 2 is working with continuous graphs. So things that aren't just distinct points, but things that are continuous, okay? And so what we're going to have to do in that instance is have a new way of writing them, okay? Because you can't list every single individual point of a continuous graph. It's not possible. There's infinitely many points. So instead what we do is we require using inequality statements. Okay, so what I mean by that is, here if I'm looking at the domain of this thing, okay, domain represents x values, right? So the domain of this thing, I see the x's starting back here, okay? They're starting at that vertex. And what x's are being used? Well, my graph is going this way forever, okay? So if I'm looking for what x values are being used, well, what I'm seeing is every x value that is greater than or equal to -4 is being used, right? That started at -4 and now it's just increasing, okay? Every x value greater than greater than or equal to -4 is going to end up being used. Now, let's look at the y values for the range. All right, for my range. So my range, again, it's starting at that value sort of, but now I see it's going up forever, right? With the arc is going to be climbing, 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 climbing forever. And same thing, the arc is going down forever, right? As you follow that arc, that green line is showing you the y values that are inevitably being used, and all of them are being used. In fact, all of them in both directions. What that's showing is any y value is going to be used at some point in this equation. So when it goes on forever in both directions, okay, so here is going up and down forever. Every y value is ultimately going to be used. We call that all real numbers, okay? And we use that fancy R to represent all real numbers, okay? So sometimes you'll see me write it out. Sometimes you'll see me use that fancy R. But both of them just mean all real numbers. Every single y value is going to end up being used here. So let's take a look at our next one. So domain. X values. Well, let's start at that unique point again, okay? If you ever have a unique point, that's kind of where my focus always begins. And if you look, that pink line is going to the right, and it's going to keep going right forever, right? Same thing as going to the left. Follow that pink line leftward. And it's going to the left forever as well. It's going to continue going in those two directions forever. So this time, it is actually my x values that are going in both directions. Every single x value is ultimately going to be used in this thing. So when every single x value is going to end up being used, we call that all real numbers. For the range, the y values, well, again, I'm going to look at that unique point. And then as I'm following the pink line up, I'm seeing every y value going upward from that vertex is going to end up being used, okay? However, nothing below it. So for the range, what I'm seeing are the only y values I'm getting are the y values that are greater than or equal to 1. Okay, I'm not seeing any y values that are less than 1 at all. So that is how we can represent those values. So let's get to some even more unique looking ones. So here I have an ellipse, okay? And for the ellipse, I'm going to start by talking about the domain, the x values, okay? So here for my x values, I notice I'm being restricted, right? My x values are stuck in between here. So again, it may help to actually show that line of here are the x's that I'm ultimately seeing, right? My x's are stuck in between those values. So what that means is to write my domain, I'm seeing all of my x values are actually stuck between -1 and 5 in this instance, okay? I am bounded on both sides. It's stuck in between those values. The x's are never getting less than -1 and they're never going greater than 5. For the range, my y values, well, let's look at those. So this is if I see how high and low my graph is going, that basically represents the y values that are being used, right? That's how high and low my graph is. So where are my y's restricted between? Well, it starts at 0, and my y values only go up to 2. Okay, that's as high as they can go. So here we were, sometimes you can get double bounded inequalities, okay? Stuck in between those values. And let's look at our last one. So domain. The domain of this graph. So I have a unique point. Now I'm going to follow that it is going to the right. Okay, so remember domain is x and is my x values. How far right and left am I going? So here, if I'm tracking where it's going to the right forever, okay? So it started when x was 0, and all I'm seeing are values greater than that, x's that are greater than or equal to 0. What about my y values? Okay, my range. How high or low is this one going? Well, this one is starting that unique point, and it's only going upward. So in terms of y, what that's telling me is my y values start at 3 and are just getting greater than that. I'm not having any y values that are less than 3 shown in this graph. So again, this is how you handle if you have continuous graphs, okay? So a really key thing to understand and know is domain and range. If you're listing individual points because you have distinct points, or if you're doing things like this because you're dealing with a continuous graph that you're looking at. So thank you for joining me for this. I apologize this one got a little bit longer for you, but make sure you have all this written down and then you can move on and you can begin working on that associated worksheet.